Okay, people, welcome back. Okay, and this is what I had up in the earlier hour. Just remember, okay, we're going into logic tonight, but just remember 85% of that final grade is based upon testing. All of the 5 tests that I give you, the midterm and the final exam, make up that 85%. So, got to work on testing skills. And the thing that I have in there, the associated test review, every test has got one of those. Use that to prepare. Now, somebody was a couple of people were asking about the dates on the Alex. And because we got next week being a day off, it kind of throws us into loop. So a bunch of stuff's going to be due here next Thursday. All right, next Thursday is a day of class. The only day we have off is Tuesday. Okay.
Right.
All right. So we're looking at a test in 2 weeks from tonight on chapter 3. And let's see. Most of those people were back here that were here. So the reason why I went to Zoom on that other test is because I talked to my boss right before, and she mentioned that the only thing I have to do the respondents for is for the midterm and the final. So I decided I wanted to do the Zoom test because I wasn't sure if everybody was right for the respondents browser. So that respondents test is going to be down here. Okay. On this one. because I want to make sure we got things running, because the midterm must be on respondus. Okay. I like the Zoom test though, because I mean, as long as I can see you, I can usually root out people that are being, if they're doing something that the school disapproves of. But that the department wants us to use that respondus browser. All right, I think that was all I was going to tell you. All right, so let's get kicking on this. All right, so chapter 3 is logic. It's really how we would say it's integral to building these things called sound or valid arguments. That's our end goal. And so we're going to look at the process of dealing with logic. And the first thing we're going to do is talk about what makes a simple statement. A simple statement is just a sentence that conveys one idea, and it's got to be well defined so as to be true or false. It does not matter which one it is, but it just has to be one or the other. So when we say Mike is a horse, it would be easy to go out. If we can find a horse named Mike, that would be true. If we can't find one, then it would be false. Fish swim in a stream. That's something that probably is pretty accurate, that we could say is a true statement. But as I had said, it doesn't matter whether it's true or false. It's just, can it be true or can it be false? It doesn't matter which one. What do you think about the one that's in blue there, that third one? Is that true or false? Y'all are alive out there, aren't you?
That's false because New
I
Orleans
can't
is not
see.
the capital of New Orleans is not the
What
capital
can't
of
you see?
Florida.
It's like so the text is so small.
What are you
I
doing it
can
on a
see it's
phone?
not.
No,
It's
I'm on my
false because
computer.
Well, you may have to zoom it in. I mean, I've got two computers that I watch my feed on, and
I can see it's false
yeah,
because New Orleans is not the capital of Florida.
yeah,
Wait,
okay, we can
no.
know that's a false statement, and it's clearly, false. So that is a simple statement. It's a well-defined statement. How about this one here? Our mascot, school mascot, is a pig. We're at Delgado. So a
I
school
don't say
mascot
that.
is a dolphin. So that's a false statement. So it is a statement. Now, statements and questions, commands. So read pages 1 through 4. Okay, that's not a statement. That's a command. Questions. How much is the doggy in the window? Those are not statements. It has to have something that has truth value, and all of these up here do have that. Oh, and if it's small, I mean, on your screen, I mean, if you do control plus sign, that might make your screen bigger, because I don't know why that would do that. But if it's text, but like I said, I'm seeing the feed on two computers, so I know what I'm sending out to you guys and what we're recording, and I can read it with no problem. And I've on all three of them. All right, so what we do is we assign letters. P, Q, and R are the standard ones. We don't go past 3 statements anyway. So usually P or Q. And then if we got 3 statements, we can put R. But the way we define a statement is we simply do either P colon and then give the statement. And then that means that whenever we use a P anywhere in our logical process, we can replace it with a P. We can replace Mike is a horse with that letter P. Okay, so that's how we do that. Now, it may have, sometimes it may have an equal sign. I know that the book does that, but I can't remember what Alex does. But anyway, it's going to be clear that they're defining a statement as such. Okay. So now, once we're able to shift our statements to symbolic, which is the letters P and Q, we can introduce these connectives. There's 4 connectives. There's and, there's or, there's if then, and there's if and only if. These are called connectives, and those have to be used on 2 statements, and they make a compound statement when we do that. Okay. All right. So here's some examples of compound statements. Fish are fried, and I'm not hungry. Winning is good, or I will go fishing. And in the if then, if it rains, then I will go to sleep. Those are all what we would call compound statements, and they're using one or more, well, at least one of these connectives. And, or, if then. Okay. All right. And we're not doing quantify. They don't have quantifiers in Alex. So I'm not going to mess with that. That's a big pain in the neck anyway. All right. So a compound statement is put together with the connectives and, or, if, then, and if and only if. Now the conjunction is called, is this one right here. It's above the 6 if you're doing it on the keyboard, like Shift 6. And it simply means and. And. It reads as and, or we replace and with it. They mean the same thing. And the and is the counterpart to the intersection over there in math in chapter 2. Yet, but, nevertheless, or also kind of mean and, but they also translate as and. Or is only got one possible thing that you can replace with or. It's called the inclusive or, meaning one or the other or both. It's called the disjunction, and it's that little thing that looks like like a V. I took the little V away. So let's use the symbolic logic to write these things in symbols only. Because we know if we define that this statement here, it says we will go to the store or we will not live. We will go to the store or we will not live. So to write that symbolically, what we're going to do is we're going to define P as we will go to the store. And Q is we will live. Now, since we're using or in there, say that, then that's going to be replaced with that little V looking symbol. Okay. Now, to write this, we're going to replace the we will go to the store with P here. The or uses the disjunction symbol. and it was we will not live. Q is always written in the positive form, so that's P or not Q. So that right there is a symbolical representation of this statement there. All right. So here's another one. We want to write this in symbols only. So P will be I will eat frozen dinners. Well, I should have read the things first. I don't think I read it. I will eat frozen dinners and I will not live to see another day. So there's two statements in there. There's the simple statement, I will eat frozen dinners, and we're assigning it P. Here is, I will not live to see another day. That's going to be our Q written in the positive form. Now we negate it here using the negation symbol. So P is, I will eat frozen dinners. There's the and, that's the one that looks like an A. And then the not means that instead of I live to see another day, it is I will not live to see another day. Okay, so that's the symbolic representation of this statement here. We have to define what P or Q are. That's our individual statements. And then the and, the or, the if, then, if, and only if get assigned based upon, the symbol that represents them. So let's talk a little bit more about the conditional, the if, and. It's symbolized by this little arrow, that little arrow there. Okay, that little arrow means if then. So here's what we want to write symbolically. If you give me some money, then I will hit the road. So the if then is the little symbol thing. So what we have to translate, or what we have to put in symbol or assign to a symbol, is give me some money. You give me some money. So that's the P. And then the second statement, I will hit the road, is the Q. So now to write this symbolically, once we've defined these two, we replace the if then with the arrow in the middle. And by definition, that's what it means. It means if P, then Q. If you give me some money, then I will hit the road. So let's do this one here. If you do not give me money, I will not hit the road. So let me annotate here. So this first one is not Q. Not Q. And then not hit the road. Oops, I'm sorry. I have it. It's not P. Not give me money. There we go. Not Q. So if you do not give me money, if not P, then I will not hit the road. Here's one that's slightly different. If I do not hit the road, which is not Q this time, then you do not give me money, which is not P. So here's the symbolic representations of these statements here. This one was just if P, then Q. This one is if not P, then not Q. This one, if it's not Q, then not P. All right, questions?
No.
All right, well, thank you. Let me know y'all are alive.
I think this chapter was pretty much explanatory. This one's much easier than the one before.
Well, good. I'm glad to hear that. I get some feedback. I mean, the first one, but you can see parallels here. They're really dealing with the same basics, which is the and, the or, and then I'll show you a few other things. So you're not learning as much as you think you're learning again, because a lot of it is just a matter of overlap. So here's another one. It's already done. I did it earlier. If I do not get a drink, then I'm going to cry. The then is, of course, understood. You may not always see it written there, but we know it's a conditional statement. I do not get a drink, which is not P, and then the if then is placed with the arrow and the positive form of Q. And then the biconditional is the if and only if, the double arrow. Remember, with the conditional, the arrow only goes left to right. There is no right to left arrow. It's always left to right. And the if and only if is the double arrow. And the way that the dominant, so connectives work, if you don't have parentheses, essentially the strongest one is the biconditional. So a biconditional state connective is going to overrule the conditional, the disjunction, conjunction, and negation. Meaning, y'all go do your stuff first, I go last, because I'm a biconditional statement. Same thing here. Then this one is next, and so forth. Okay, so now let's kind of go the other way and go from symbols to words. So there's P. And then here's Q. All right, so they're being defined for us. So then that means if we see P and Q in here, we can go up there and see what they represent, and then replace those with the words, and then take into account what that symbol is. All right, so on this first one, all right, so not P, and P is suspect is guilty. So that's basically just saying the suspect is not guilty. It doesn't have to be capitalized or anything. So because P is the suspect is guilty, then not P means the suspect is not guilty. This is P or Q, so that's the suspect is guilty or the witness is lying. All right. Now on this one, see, we're still using the same P and Q until P and Q is redefined. We just keep using the same one. So now that's if not P, then Q. P is the suspect is guilty, and that's not P. So if the suspect is guilty, the witness is lying like a rug. So here's your P right here. The suspect is guilty. Oh, it's not guilty. There we go. I knew I was missing something. So this is the if and only if. So we're just stringing together P and Q with if and only if in the middle. This is P. I'm just going to stop it there because it's going to run off. That was enough. Imagine it says line like a row. All right. And then this is the last one. This is just P and Q. So we're still using the same letters, except we're just replacing the symbol with words now. Suspect is guilty, and the witness is lying like a rug. All right. All right. Questions? All right.
No.
All right.
No question.
Okay. So let's look at one thing, and this dates back to that dominance of connectives. And so in the conversion between symbols and words, a parentheses corresponds to a comma. All right. So let's look how that works. So this right here is simply if Q, then not P. So since P is the plane is on time and Q is the sky is clear, then this would be written as if Q, if the sky is clear, then the plane is not on time. That's how that one would be written. Now, generally, for a conditional statement, you're just looking at the comma in between the two where the little arrow is at. But now here, if we've got a more complex statement here, in other words, we've got if Q, then P or not P, that means that those parentheses is our whole antecedent. All right. That parentheses right there makes that all one statement, essentially. It's a compound statement. So this opening of that parentheses then is where we start the comma at, meaning that if Q, if the sky is clear, then everything that follows the word then is our consequent. So that is, then the plane is on time or the plane is not on time. All right, so this one is just an and. There's no real need for the comma here, but if there had been, and we'll see over here on this one, it makes sense. But let's go ahead and just do this one. This is just not P and not Q. So not P is the plane is not on time. The hat is the and the not Q is the sky is not clear. All right, now again, we got a parenthetical part here, and the one in the middle is an or now. So this is what we would call an or statement. And so what that parentheses is doing, it's forcing the more dominant one, the arrow is more dominant than the or. So that parentheses is forcing that if P then Q in there to be done first and be part of that or. So when we close that parentheses, that then is where the comma comes in and represents a comma. So if the plane is on time when the sky is clear, or the plane is not on time. So that comma is just showing us that all of this part goes together and is the first part of that or statement. Okay. Now, truth tables is one of those kind of sticky subjects because it's much the same as those set operations over in chapter 2, you know, where you had A union B complement intersected with B complement. And you have to basically start from the inside out and work and find out which each of the ones are equal to, and then you finally put them together last. Well, it's the same kind of thing here with a truth table. Now, what we start out with are these basic truth tables, and we talked a little bit about them up there before, but the negation is basically you only got two possible outcomes when you're negating a statement. If you've got a true statement and you negate it, the negation is obviously false. If we start out with a false statement, then the negation is going to be a true statement. And those are the only two possibles. All right, so this right here, I changed this for my class last night. So let's change it back for you. Okay, today is true, which is a true statement. So the negation is today is not Tuesday, would be false. Now here's another one here. This one is going to be false. It says this class meets at 2 p.m. Well, that's obviously a false statement because we meet at 7 p.m. So the negation would be this class does not meet at 2 p.m., which is true. True. Okay. So that's the two possibles here. Start with a true statement, the negation is false. Start with a false statement, the negation is true. Now, when we get to and I got this little thing in here to bring harken back to chapter 2, and this is the Venn diagram for what we call the intersection, and the intersection is and. Because you remember when we had a Venn diagram with 2, that inside section, that's the one place. Remember, there are 3 different regions. You know, there's this one right here. There's this one here. There's this one here. And there's this one here. So this over here, the white one with the 1 in it, that's just A only. The 3 is B only. The only place where you're in both A and B is here in that one that I've got labeled as 2. And that's the one that represents the intersection, also known as the conjunction. All right. So now, the conjunction is one of those connectives that allows us to build a compound statement from 2 simple statements. Okay. So here are the possibilities. Now we got 4 possible outcomes because we're dealing with 2 statements. So if the first statement is true and the second statement is true, then it's true because that's saying you're in both. But if you're over here where you're in the first, but yet not in the second, in other words, this side is true, this side is false, then it's a false statement because when you say and, you have to have both. So that's also why case 3 is false. Because if you're just in the B, but not in the A. You're not anding. You're not in the intersection. You're not in the both. And clearly, if you're out here in that region 4 out there, then that's false because you're in neither one. That's essentially the complement of that, the whole of the two circles. So I put this here because of the fact that this can help show you that you're really not learning anything new here. It's that same concept, and we're just dragging it into the set theory. And as I might have mentioned earlier, over here, this is the conjunction symbol, that little hat. Well, in the logic, it's the counterpart to the little intersection sign, and over there that means and. You're in both. All right. So for or, it works similarly, except remember or. Oops, let's see. Let me see if I can write these back. See, this is the 1. Inside is a 2. 3 is out here in B only. And then this is the 4 outside. So essentially, when you're just saying or, you're saying if we're somewhere in the union, in other words, we're here and here where they're both true, then we're in the union. That's the both, just like for the and. For case 2, if we're over here, we're not in B, but we're still in the union because we're in the A. A only is part of the union. Same thing for this third one. If we're over here in that region 3, then we're in B only. We're not in A at all, but we're in the union of those two. And then the fourth case, just like the false for the last one, for the case 4 for the and, for the conjunction, this one is false also because it's out here and it's not in the union. Okay, so those are the two ones that harken back to the union and the intersection, or the intersection and the union. We'll get to mention the other ones first for the conditional and biconditional. I'll show you a little way to relate it back. But okay, let's say we want to build a truth table, and I should have enough room here to do it. So the little truth table thing in Alex is neat. You don't have to draw anything out, but it does have the ability to add as many columns as you want, which is a good thing. Take advantage of that because again, these are steps. These are like those order of operations things that we did with the set operations. Same kind of thing. So we got 2 statements here. We're going to build a truth table for this statement here. P or Q and not P. We're going to build a truth table for it. And what that'll tell us is all the possible scenarios, what the truth value will be for that statement. All right. So following standard procedure, 2 truths, true falses. And as I said with Alex, you get this part. They give it to you. So there's the 4 possible ones. True, 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 false, false, true. False, false. All right. So generally, just like with the set operations, with this, we're going to work from the inside out on the most complicated part, generally going right to left. And inside of these parentheses is that indeed most complicated part. So we're going to write right here. Let me see if I can type it in there with the text. There we go. All right. Now, really, all we're doing is we're just reiterating what we essentially got up here with the disjunction. This is just the rehash of that because all we're asking about what is the truth table for P or V. Well, this is it. It's true, 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 false. Because as long as you got one T in there, it's true. So that's true. That's true. That's true. And this is false. The reason that last one is false because it contains no truths. We're essentially looking at this here, the conjunction. So as long as it's in one of those first 3 parts and not on the outside, it's true. Now, what was the other thing? There was another part to it. Then we got to have not P. So then what I'm going to put here, not P. See, we know what P is, but we don't know what not P is until we go over here and we take the opposite of every one of these P's. So true, true, false, false becomes false, false, true, true. Okay. So now what's going to be here is the whole thing. I'll just write it out here. But the important thing is the connective. All right. So what we're really paying attention to are these 2 lines. I'm sorry, 2 columns. We're paying attention to this column and this column. See, that's this part and that part. We've condensed P or Q down to 1 column, and we've condensed not P down to 1 column. Now we're doing the operation here. In other words, we're using and to put these 2 together. And so what and was, the conjunction is only true when both P and Q are true. Otherwise, it's false. It's just got to have one false to spoil it. So true, false is false. One false spoils the and. True, false, false. True, true, though, is true, because true, trues is the only case when the and is true, and another false true is also false. So then this column right here, this thing right here, are the truth table values for the statement that we originally started with which is this one here. See that one? All right. So any questions about that? Because I mean, I'm got plenty of time here.
So far, so good. I guess we just have to practice it.
Well, that's it, and that's why what I do is I try to have the lecture the material pretty quick to just give you some insight on it. Then if you start working on your path, then you can bring questions back. And then once we get in testing mode, you start going to the review, and then that's when I start going over that review where the problems are more like problems that you're actually dealing with and that you've had a chance to work on them. Okay. All right. So here let's talk about the conditional and the biconditional. The conditional is the one of these connectives that has to do with order. All right. Now, when we got a conditional statement, the first part is called the antecedent. So if P, then Q. In other words, so the P, whatever this is, that one that follows if is the antecedent, and then the one that follows then is the antecedent. I'm sorry, the consequent. And then what that means is the consequent comes upon fulfilling the antecedent. In other words, that's the condition for this to happen, that this first part happens. Now, this is always true 3 out of 4 times, but here's the one that usually throws people for a loop because it goes like this. If the first term is true, has the value, and the second has a value of false, then it's the compound statement is false. And the reason being is because you can see in this illustration, this is an illustration from chapter 2 about a proper subset. And remember, a proper subset is when you have a smaller set that's fully contained within that larger set. And the relationship between these two is if A is a proper subset of B, then it means if it's in A, then it's also in B. Okay? So what this is, that second case, is a lie. Because if we're in A and we're not in B, we got a problem. And that problem is that's a false statement compound. So the other ones don't matter because if we're not in A and then we're still in B, and the other is as well. But this is the one case, and this is the one that's order dependent. If your antecedent is true and your consequent is false, then that's the only time that the conditional is false. Remember, we got 4 different ones of these. They're all got different rules. So you have to be able to distinguish them. And I got a little sum up page in a second. And then the biconditional works like this. A biconditional essentially just means equivalence. So if the truth values, in other words, the antecedent and the consequent are the same, doesn't matter about order, because if they're the same, if they're 2 truths, then it's true. If they're 2 falses, it's also true. The only time it's false is if they're unmatched, true false or false true. And that relates back to the idea of the equal sets. So let's see if we can build a truth table. And then I'll give you that if you want, and I'll tell you what I would recommend doing with that. All right, so we're going to build a truth table. Let's build it for this one here. So I'm going to do the same thing that I did over there before, which is draw a little chart. And I should have enough room in here. So I can't really draw a text box vertically, so I'll do these by hand. So there's the P and there's the Q. See, we got two statements there, P and Q. So that means we're going to have 4 rows. Two trues, 2 falses. Okay. So there's the 4 possible combinations. Now, what we got to do is we're going to build this. First one, we're just going to go left to right. So what's going to be here is just the basic conditional statement that we just looked at. Okay. So now let's go back up there and look at that. The conditional. This is the one where if the antecedent, in other words, the P is true and the consequent is false, then that's what this represents. Let's see if I can, I was wanting to keep that in the frame. I don't know if I can do it, but we'll try it with this. So see, true, true is true. And this is that second one. That's the one here, the case 2. If you align these like that, true, true, false, false, and true, false, true, false, then it will be here always. So those are just those values there. Okay. So let's go back down here and finish that up. So that's this whole left side right there. That's the left side. All right. Now we want to build the right side. And here's the thing that I suggest. I can't really do it here like it does in Alex because I'm doing it by hand, but they have a nice little tool where you can add in a column that essentially gets ignored when it comes to the grading. They only look at one column. So what I'm going to do here is put a line there. Now, what I'm going to do here, and it's going to look like kind of weird, but it'll be helpful because it's easy to make a mistake with these, because one of the problems that I have is if I try to skip over columns when I'm reading these, I'll invariably, miss something. So what I'm going to do is I'm going to write my Q and P, because what I need to have over here is if Q, then P. See, it's the backward ones here now. It's just a different direction. So what I'm doing is I'm going to put them in order now so because the conditional is the one where order matters. So I'm just going to put them in the reverse order here. So this is true, false. So there's just been swapped around. And the reason why I do that is because I don't read too well backwards. And also, too, you got to read over this middle one that we've already done. So that can be confusing. So I'm rewriting them. And now I'm going to still follow this rule up here for the conditional. All right. I can't do that. I want to do that. I was trying to just take off the bottom, but I can't do it just so you could see this a little bit better. But we're still following in the same order, where if the antecedent is true and the consequent is false, it's going to be false. But watch what happens on this. We're going to follow. So true is true. We said over here, false true is true. See, and now in the second position, we've got false true and not true false like we did over here. But it swaps places now. Now it's in the third position. So there's the false one. There's the true one. Now, let me see if I can do this because I don't really have enough room to write another column. So what I'm going to do is I'm going to put a line here. And I'm going to put in this spot here, right there. Let's see, what was the... It was and. So I'm going to just put right here the and symbol, because that's really all we're looking at. But what we're doing is this whole thing is what we're building right there. This is the last step, because we got the left-hand side, we got the right-hand side, and we're going to put them together with the and symbol. Now, the ones I'm looking at now, like I said, is I want to kind of just cross these out so we don't look at them. And we're only going to look at this column, and we're using the and rule. And the and rule is only true if we've got two truths. Otherwise, it's false. So what I like to do is I'm just going to come up here and find any that have two truths. There's the two truths. This is the two truths. Both of these other ones have one false, so these are false and false. All right, now you'll have some of these to do, and then these things will be different for the most part. And if they're not exactly the same, as we talked about in the last class about equivalence, if they're exactly the same for two different statements, then they're what we call equivalence. Now, you might notice this right here is the same thing as the biconditional. So this statement right here is an equivalent statement to the biconditional because it has the same order of true being true, and true being true. And then the mixed ones, false true and true false, are false in the middle. So that right there is the same thing as the biconditional. Oh, and just two terms. Okay, this could be all trues, it could be all falses, or it could be true false true false. There's any number of combinations. But if they're all falses, it's called a contradiction. And if they're all trues, it's called a tautology. And it's just a definition. It's all that means when you see those words. So let's sum all these up. Let's sum all of these up, the 5 different ones. And this is kind of a more of a traditional truth table, but you can also go back up there and use the sentence description that I give. That's the way I remember them. Okay, so what might be a good idea is take a picture of that, and as you're working through your path, that you can look at this until you get to know them, because by midterm, you kind of got to know these without bringing any kind of cheats to the game. In other words, for the midterm and the final, you know, you're doing notes. That's why it's important, as I had said too, about this over here. "85% of the finals grade is based upon testing," okay? That path, that whole thing that is paced for you to keep up with, that's just 10%. And you know what? Alex never lets anything out of your path that you don't master. So even if you're behind on the dates, you still will get that material. It will not let you go on. It will not let you pass go until you have mastered. And even when you've mastered something, even if you do it before the due date and you got 100, if you fail a question in your knowledge in a subsequent knowledge check, then it will reduce that score. So the 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 path, the 10%, is a hard thing to get perfect. So that's why I have that one as number 2. No matter what your shape you're in, when you're starting to get between 5 days to a week before the test, look at the associated test review and start working on that. I can predict with about 95% accuracy what someone will do on the actual test based upon their test review score. The test review allows you to take it multiple times so that you can each time go in, review after the first one, see what you did wrong, try to correct it, then come back and take it again. All right. So that's what that's for. And generally, when I find people that do well on the test, they've taken advantage of that. So you take advantage of it. And like I said, it's one test that we look so past so far. That's a very small percentage of the grade. The major tests are the ones we got to proctor, and where they enforce the rules about specific calculator, the TI 2x thing, and no notes kind of thing. All right, let's see what we can get into with the last few minutes, and then that way, maybe Thursday we don't have so much to do to finish up this chapter. So, like I said, take a screenshot of that, print it out. You can put it on your phone, so long as you're not testing. You can refer to this until you learn these, because these are going to be with you till the end of the course. They're going to be on the next test. They'll be on the midterm. They will be on the final. You cannot hide from these. All right. So make sure you're able to distinguish between each one of these: the and, the or, the if then, the if and only if. See, they're all different. You cannot mix them up. And then the negation is the simple one because it's just the opposite. All right. So equivalent statements and the Morgan's laws. All right. Um, if two statements are equivalent, or two statements are equivalent, if they have the exact same truth values for the truth tables, not just that they both got two F's and two T's. They have to have them in the same order. So for De Morgan's laws, which are equivalences, the ones from chapter 2 as well, the truth table for the left-hand side is the same as the truth table for the right-hand side. The negation of P and Q is equivalent to, not P or not Q. The negation of P or Q is equivalent to not P and not Q. Now there's one more equivalence that we're throwing in here in addition to these De Morgan's laws. All right, and the conditional statement is this. The conditional statement is equivalent to not P or Q. And now why would we want that equivalence? Because if we want to negate a conditional statement, then we don't have any way to do that. But if we have a statement that's equivalent to it, that's written with a U, the or. What happened there? Ah. Then we can take this one and use De Morgan's laws on it and then find the negation of that conditional statement. So this right here is an equivalence that the conditional statement is equivalent to not P or Q. So then using De Morgan's law, in other words, if we take this part right here on the right-hand side and negate it, negate the whole thing, then it negates the P, which is already negated, so it just makes it into a P. It changes the or to an and then the negation just gets passed off to the Q, which just takes the negation sign because it doesn't have any sign on it. So then here's another equivalence. You will need those three. And so this is just to show you that they have the same truth values. So that's why they're equivalent. If these are already done for us, but so these are the three right there that they're going to be picking on you about when they ask about equivalence and negation of statements. So let's do kind of one set of problems here. And the thing we're going to work on first are these variations of the conditional statement. All right, so the conditional statement is just the basic if P then Q. All right, if P then Q. Well, it's got if we take them in swap places, swap the antecedent and the consequent, it's called the converse. The converse. If the antecedent and the consequent, it's called the inverse. And then if we do both, in other words, if we take the converse and then negate each one of the antecedent and consequent, it's called the contrapositive. And these two are equivalent. And these two are equivalent to each other. They're not all four equivalent to each other. And when you have some problems in here, when they ask you to do these, there you will find out they travel in pairs. In other words, conditional and contrapositive are the same. They're equivalent. And then the converse and the inverse are equivalent to each other. So let's do one of these real quick before we stop for the evening. Okay, so what we're going to do, and this is just showing you the truth table. See how the conditional and the contrapositive have the same truth values. And these have the same truth values. All right, and this kind of explains it. They just call it a hypothesis and conclusion. I borrowed that from a teacher, another teacher. All right, so let's say we start out with this conditional statement. If a dog is a Great Dane, then it is large. If a dog is a Great Dane, then it is large. All right. Well, the first thing we want to do is break this down symbolically. So we're going to let P be equal to the dog is a Great Dane. And then the Q, the consequent is Q is equal to dog is large. So now, this right here is the conditional statement. So going back up here, see, the conditional is the one we're given. We're going to create the converse, the inverse, and the counterpositive. So I'm just going to write here. I don't want you to see the answers yet. That's no fun. So this is the conditional. All right, so what we're going to do here is we're going to do the counterpositive right down there on the bottom. I'm sorry, the converse. So now what that means is, let me put this right here. This is P2, oops. This is Q, P. All right. So now, that's if Q. So if the dog is large, then it is a Great Dane. If I can get back in there. I wanted to put it on one line, but I can't get back in there to get it to. All right, for the sake of time, let's go ahead. So that's the converse. See, I've just turned the two around. The inverse would be when we negate. So this is going to be not P, not P, not Q. So this, if the dog is not a Great Dane, the dog is not large. All right. And then the last one. See if I can put it down there. I want to make a real long one. So this one is going to be the contrapositive. So this is, if not Q, so if the dog is not a Q, not large, the dog is not a Great Dane. So there we go. There's all the four iterations of it. And actually, these two are equivalent statements. And these two inside here are equivalent. And if you read them to yourself, you might be able to convince yourself that they mean the same thing. Because if the original statement, if a dog is a Great Dane, then it is large, that's not the same thing as saying the converse, if the dog is large, then it is a Great Dane, because there's other large dogs. if you've got a large dog, it could be what is it? Saint Bernard, whatever else is big. Same thing. If the dog is not a Great Dane, the dog is not large. Again, that's not true, because if it's not a Great Dane, you don't know what size it is. It could be another dog that happens to be a small one. But this one is as true as the first one is. If the dog is not large, then it can't be a Great Dane. It's not a Great Dane. All right, so that should be enough for tonight. We need to both have some more energy on Thursday, because I want to send y'all out. I know that we got a break coming up, but we can't just not do anything, because it's all going to come back to roost. All right, if you got any questions, stick around. Otherwise, I will see you Thursday.
Thank you. See you Thursday.
Bye-bye.
Bye.
See you Thursday.
See you Thursday.
See you Thursday.
Okay,
Good night.
bye-bye. All right, David, Kaylee, Malika, y'all got any questions, or y'all just
I think we're good.
okay? I just want to make sure.